Dear students, let us recall what is the rational function. The function of the form p of x divided by q of x, where p of x and q of x are both polynomials, is called a rational function. It is called proper if the degree of p of x, that is the degree of numerator, is less than the degree of denominator, that is degree of q of x. Then it is called proper. Otherwise, it is called improper. Today we are going to discuss the integration of both proper and improper fractions. So dear students, we have understood what is improper and proper rational functions. Now we are going to do one method of integration where we have proper rational functions. If we have a rational function of the form p of x by q of x and the degree of numerator is less than the degree of denominator, there is one method called partial fractions by which we can easily solve the integrals. So dear students, let us discuss one form of a rational function where we have in numerator we have px plus q and denominator we have x minus a and x minus b, where these are linear factors and a is not equal to b. Now you can see that the degree of numerator is less than the degree of denominator. Now there is a mathematical tool by which we can separate these in the form a upon x minus a, where this linear factor has been separated in the denominator, and plus b upon x minus b. Now a and b are both constants. By this way we can easily find the integrals of this type of forms. Now dear students, let us solve one problem based on the previous expression. Now you can see we have dx upon x plus 1 into x plus 2. You can see there are two linear factors in the denominator and in numerator we have only one. Now before integrating, let us do some partial fractions where we can split these factors in the form a upon x plus 1 and b upon x plus 2, where a and b are some constants. Now let us see how to find these constants. We will cross multiply the whole polynomial from the left hand side to the right hand side. We will get a into x plus 1 into x plus 2 divided by x plus 1. We will have only x plus 2 and b multiplied by x plus 1. Now when we open the right hand side, we will get ax plus bx. So we can write a plus b times x plus 2a plus b, whereas we have only 1 on the left hand side. Now we can write this as 0x plus 1. Now we can compare the coefficients of x and the constant terms on both sides. So comparing coefficients of x and constant term on both sides, what we will get? On the left hand side we have 0 as the coefficient of x, and on the right hand side we have a plus b as the coefficient of x. So by comparing we can see that a plus b is equal to 0. We'll make this equation number 1. Now we have left hand side we have 1 and on the right hand side we have 2a plus b as a constant. Now we will again compare this and 2a plus b will be equal to 1. We'll give this equation number 2. Now we can solve this by elimination method. What we will get? Now we'll subtract these, we'll get minus a is equal to minus 1, that is a is equal to 1. We'll put a is equal to 1 in equation number 1, we'll get b is equal to minus 1. Now we have a and b available with us. Now we can easily integrate this function because we know that integral of d of x upon x plus 1 will be of the form a upon x plus 1 and b upon x plus 2 dx. Now we already know what is the value of a and b, so we'll put here a is equal to minus 1, sorry, a is equal to 1 and b is equal to minus 1. So now we can easily integrate using the standard integrals. Here we have 1 upon x plus 1 whose integrals are, whose integral is 1 upon x plus 1 integral is log of mod x plus 1, and the integral of 1 upon x plus 2 is log of mod x plus 2 plus c, which is the constant of integration. Now we can write this in the form log of mod x plus 1 upon x plus 2 plus c, which is our final answer. So you can see how we have done the partial fractions where we have a rational function, and it was very easy to integrate if we have reduced these into the partial fractions. So dear students, let us see some more partial fractions. We have some forms of rational functions. Now you can see we have px plus q, which is a linear form, and we have x minus a whole square, which is a repeated linear factor. In the previous case we have done non-repeated linear factors. Now in this case we have repeated linear factors. Now in this case the form of the partial fraction will be a upon x minus a and plus b upon x minus a whole square. Now we'll see the third form, that is we have the quadratic expression, quadratic polynomial in the numerator, and we have three linear factors which are three linear different factors in the denominator. Now we can see that the partial fraction form of this is a upon x minus a, where x minus a is one linear factor, b upon x minus b, and c upon x minus c. Now in the third form we can see that all these linear factors have been split. Now in the fourth form we see that we have the quadratic expression, or it could be a linear expression. What is the condition? That the degree of the numerator must be less than the degree of the numerator. So we took a general case. Now in that case you can see that we have a repeated linear factor x minus a whole square and another factor, that is x minus b. In this way we can see that the linear factors can be split in the form a upon x minus a and repeated linear factor b upon x minus a whole square, and the third factor, which is x minus b, will be written as c upon x minus b. Now in the last case we can see we have a polynomial in the numerator whose degree is less than the degree of the denominator, and we have some linear factors, and we have a quadratic expression, quadratic polynomial, quadratic factor in the denominator. In this we can see that the partial fraction will be of the form a upon x minus a, where x minus a was the linear factor, and bx plus c upon the quadratic factor. You can see that the degree of this partial fraction in the numerator we have degree 1 less than the degree of the denominator. So these are various forms to split the partial fractions. So dear students, let us solve some more problems. We have x upon x plus 1 into x plus 2. Now we can see that the degree of the numerator is less than the degree of the denominator. Now we'll use the partial fractions. We will rearrange these terms to get a upon x plus 1 plus b upon x plus 2. Now we'll cross multiply to get a into x plus 2 plus b into x plus 1. Now we'll compare the coefficients of constant term and the coefficient of x on both sides. We'll get a plus b is equal to 1 because the coefficient of x on the left hand side is 1, and the constant term, which will be 2a plus b, will be equal to 0. By solving these two, we'll get the values of a and b. We can use the method of elimination to find a and b. So what we will do, we'll eliminate b, we'll get minus a is equal to 1, so a is equal to minus 1. We'll put the value a is equal to minus 1 in equation number 1. What we'll get, b is equal to 2. So these are the values of a and b. Now we will use the partial fractions to split this. We'll get a, that is minus 1 upon x plus 1 dx, plus the second part would be 2, that is b upon x plus 2 dx. Now we'll simply integrate this. So what we'll get? We'll get log of minus log of mod x plus 1 plus 2 log of mod x plus 2. So, what we will have now is log of x plus 2 whole square, because having the property that 2 log of x plus 2 is log of x plus 2 whole square will be this, and minus of log of mod x plus 1 will be like this. Now, we'll have the final answer log of mod x plus 2 whole square. We can write here mod, or otherwise the square was already present, so we can skip mod also. So, what is the final answer is log of mod x plus 2 whole square divided by mod x plus 1 plus c. Now, let us see one more problem in which we have 3 linear factors in the denominator and the degree of the numerator is less than the degree of the denominator. Now, we can use the partial fractions to split this rational function, which is of the form a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. So, what we will do, we will cross multiply the denominator on both sides. What we will get, a into x minus 2 into x minus 3 plus b into x minus 1 into x minus 3 plus c into x minus 1 into x minus 2. So, by comparing the coefficients, we will get a is equal to 1, b is equal to minus 5 and c is equal to 4, like we have done in the previous cases. In this case, we will compare the coefficient of x square on both sides, x on both sides and the constant term on both sides, because there are 3 variables present. So, we will have 3 equations and we can solve 3 equations to find the 3 variables. Now, what will we get is integral of a upon, that is a upon x minus 1, that is 1 upon x minus 1, plus integral of minus b, now we can write b as minus 5. So, this is minus 5 upon x minus 2 plus c is 4, that is 4 upon x minus 3. Now, we can simply integrate using the standard integrals. We will get log of mod x minus 1 minus 5 log of mod x minus 2 plus 4 log of mod x minus 3 plus c. This is our answer. Now, dear students, let us take one example where we have the degree of numerator is equal to the degree of the denominator. So, in this case, this is not a proper fraction. So, what we have to do is we have to simply divide the numerator by denominator. So, we can rearrange the terms also. What we will get? We can rearrange this way, that we can write x square minus 5x plus 6 and plus 5x minus 6 plus 1. What we have done is we have simply rearranged the term so that we can simply divide the denominator using a method of rearrangement, but it was actually a division. Now, what we will do is we will able to find the quotient and the remainder in this way in the very easy manner. So, what we will get? We will get here 1 plus 5x minus 5 upon x square minus 5x plus 6. Now, we will have 2 parts here. One part is a constant integral and the second part we can see we have numerator by denominator, that is a rational function, but where a rational function, in that we can see that the degree of the numerator is less than the degree of the denominator, and we can also see that the denominator is factorizable with different factors. Now, we will split this in 2 parts. One is integral 1, that is this part, and the another is integral 2, that is this one. So, we can simply use the standard integrals to find the integral of 1, that will be x. Now, we will try to find the value of I2, that is 5x minus 5 upon, now we will split this using the splitting the middle term method. What we will get here is x minus 3 into x minus 2. Now, we will use the partial fraction method to solve this problem. 5x minus 5 upon x minus 3 into x minus 2 can be written as a upon x minus 2 plus b upon x minus 3. Now, by cross multiplying this, what we'll get is 5x minus 5 is a times x minus 3 plus b times x minus 2. Again, comparing the coefficients of x and the constant term on both sides, what we'll get is a is equal to minus 5 and b is equal to 10. We'll use this to find the integral I2. So I2 will be of the form minus 5 upon x minus 3 plus 10 upon x minus 2. That is minus 5 log of mod x minus 3 plus 10 log of mod x minus 2. So our final answer will be the addition of these two plus the constant of integration. So our final answer will be x plus, we have minus 5 log mod x minus 3 plus 10 log mod x minus 2 plus c. Dear students, now we'll do one more method, which is a very interesting method in which we have the rule where we can integrate the functions which are already in the multiplied form. Let us consider that rule, which is called integration by parts. Where we have two functions f of x and g of x. The integral of this will be of the form f of x into integration of g of x dx minus integral of the derivative of f of x and integral of g of x multiplied and the final integration of that. So let us take one example where we can apply this formula. Let us take one example. We have x sine x dx. Now let us consider this function as f of x, that is first function, and this function as second function. Let us integrate using the formula. Now f of x is x here, so we'll write x here, and the integral of sine x minus integral of derivative of x, that will be 1, into integral of the second one, that is integral of sine x. Now the integral of sine x is minus cos x, that will be minus x cos x minus, now integral of sine x will be minus cos x here again, so it will become plus and integration of cos x dx. Now the integration of cos x will be sine x, so the final answer will be minus x cos x plus sine x plus c. So we can see that we have integrated using the above formula, but what if we take sine x as first function and x as second function? Then it will be a never-ending process. So we have to select the first and the second function wisely. Let us deduce one rule to easily select that priority of the function. Now, how to choose the first or the second function can be deduced by a rule which we call it as Iit rule, in which I means inverse trigonometric functions, L means logarithmic functions, A means algebraic functions, T means trigonometric functions, and E means exponential functions. This is the priority rule. If we take the integrals of first and second function in this order, then we will be easily able to find the whole integral. For example, in the last question, we had x sine x. What we have chosen is algebraic function a as first function and t as trigonometric functions. Dear student, you can also try by taking the trigonometric function as first and algebraic as second. You can see it will become a never ending process because the integral of x will be x square and so on, it will go on. So it will not be in the integrable form. So we have to wisely select the first and the second function. Now what if we have only a logarithmic function available with us? If we have logarithmic function or any of the inverse trigonometric function available with us, then we will multiply this by 1 and will take log x as first function and the second function as algebraic function 1. So even if we have sine inverse x, cos inverse x, tan inverse x or any inverse trigonometric function, instead of log x, we will do it in this manner. So the first function is log x, we will keep it as it is. Now the integral of the second part, that is 1, minus integral of the derivative of first part, that is 1 by x, into integral of the second part, that will be x dx. So what we'll get is integral of 1 is x, so we'll get x log x minus the integral of 1 is x plus c. So this is our final answer. Now let us solve one very interesting problem. In this case, if we'll take e raised to the power x as first function and sin x as second function, then we'll be able to easily find the integral. So what we have discussed earlier was the Eilert function, in which we choose e raised to the power x as the last function in the priority. But in this case, we will choose e raised to the power x as the first function, because the priority here says that whichever function has integral easy, that we will choose as a second function, and whose derivative is easy, we will choose it as a first function. In this case, the integral and derivative of both has the equal priority. So we will take e raised to the power x as first function and sin x as second function. So what we will do, e raised to the power x, integral of sin x is minus cos x. So we will directly write here minus integral of e raised to the power x, derivative is e raised to the power x, and integral of sin x will be minus cos x. So it will be minus of minus plus cos x dx. Now we are and with the integral of the similar kind of form. Now we'll integrate again. So it will be of the form e raised to the power x, cos x integral is sin x minus integral of e raised to the power x sin x dx. Now we can see where we have started, we are ending with the same kind of function I. So I'll put it I. So I is equal to minus e raised to the power x cos x plus e raised to the power x sin x minus I. So we'll take this I on the left hand side, we'll transpose this. So what we'll get is 2i is equal to minus e raised to the power x cos x plus e raised to the power x sin x. So in this way we could easily find the integral, that will be half of minus e raised to the power x cos x plus e raised to the power x sin x divided by 2. Now we take f of x as first function, what will get f of x, and the integral of second function e raised to the power x will be e raised to the power x minus derivative of first function, that is f dash x, into integral of second part, that is e raised to the power x dx. When we write plus I2, it will be e raised to the power x f dash x. Now you can see that e raised to the power f dash x dx is present with the minus sign and with the positive sign. So it will be cancelled. So what we are ended with, e raised to the power f of x dx plus c, which has been proved. Now dear students, we can see that we have the integral of the form e raised to the power x tan inverse x plus 1 upon 1 plus x square. You can easily correlate with the standard form e raised to the power x f of x plus f dash x, which will be equivalent to e raised to the power x f of x, which is e raised to the power x tan inverse x plus c. Dear students, we can see one more form, e raised to the power x 1 upon x minus 1 upon x square. Now we can easily see that the derivative of 1 by x is minus 1 by x square. So we can correlate with the standard form. This will be f of x and this will be f dash x. So the answer would be e raised to the power x into 1 by x plus c. That is e raised to the power x by x plus c. So dear students, in today's lecture, what we have understood how to integrate the rational functions. We have also understood how to use partial fractions. We have also done one very interesting method, that is integration by parts. So I hope you have easily understood the lecture. Thank you.